Which ball is safer to catch? And why do some catches hurts and others don't? This all is linked with understanding of momentum. So our today's lecture is about understanding what is momentum. What is momentum? Momentum is mass, time, velocity, and it is a quantity of motion an object has. So this here you see P equals m times v is momentum, and this represents how much motion object have, and it depends upon two things: number one, mass; number two, velocity. So as the velocity is vector quantity, so that the momentum is also vector quantity, and unit of momentum is the unit of mass times the unit of velocity. So kilogram meter per second. So this is the unit of momentum. Now let's calculate the momentum of object. If the mass of object is 2.5 kilogram and 3 it moves toward right with the velocity of 3 meter per second, then by multiplying these two you will get momentum, and that is equals to 7.5 kilogram meter per second. So this is m, this is v, and this is your momentum. So as this is vector quantity, so this is also vector quantity. It means this momentum is also toward right. So as soon as we see that momentum depends upon velocity, so in case of rocket, as the velocity of rocket increases, its momentum also increases, and the rocket momentum increases. But total momentum is conserved, that we will study in future lecture. Now, students, momentum, what is the relationship between momentum and force? And for this, we need to understand Newton's second law. We need to deal with Newton's second law, and that is equals to m times a. Force is equals to m times a. This relates force with the mass and acceleration. So if you have more force, you will have more acceleration. So similarly, you know that acceleration is related with velocity and our time. Acceleration is the rate of change of velocity. So if we place this one here, we will get something like this. And the velocity, change of velocity is final velocity minus initial velocity. And if you see this one, this will give you mass times velocity and final momentum minus initial momentum. So you can write mvf minus mvi and divided by delta t. So this quantity here is equals to, this is equals to, this part is equals to change in momentum. This is final momentum and this is your initial momentum. So change in momentum, our change in time is equals to force. So this is actually, these two are the Newton's second law, but this is expressed in terms of acceleration, and this is expressed in terms of rate of change of momentum. So if you apply a force on any object, it will it's going to change the momentum of object with time. Or if the momentum of object is changing with time, it means that there is a certain force acting on that object. So according to second law of motion, now according to this equation, we can rewrite the second law. The force applied to object is equals to rate of change of its momentum. This is one of the most important expression you have, because with the help of this we are going to answer our questions which we asked in our previous slides. Now let's come back to our questions which I asked in previous first slide. Which ball is safer to catch, ping pong or baseball? What do you think? Yes, students. The ping pong ball is safer. Why? Because it has much less mass. So if the mass is less, so even when it is moving faster, its momentum is small. This results in a much smaller force when catch. So if mass is small, although the velocity is same, but the mass is small, so momentum is also small. So if momentum is small, the force and momentum, they are directly related. So if the momentum is small, then the force will be small. So it is safer for ping pong ball to catch as compared to baseball, because baseball will have more mass and it will have more momentum, and if we have more momentum, it will have more force, so that can hurt your hands. Would be careful. Another question I asked was, why do some catches hurt while others don't? A baseball has more mass, so for same speed its momentum is larger than a ping pong ball. So baseball have more mass and the speed is same, but momentum is larger. So when you catch, suddenly the t is very small. This time is very small. So if time is small, the force will be larger because these two are inversely related. And it hurts. So when you move your hands backward while catching, you increase the time, which reduces the force, and the catch does not hurt. Right? God having a mass of 900 kilogram is moving toward due east with a velocity of 10 meter per second. Calculate the momentum of the car and the change in momentum when the velocity of the car increases to 30 meter per second. So as I highlighted the main things with the red color, so you can easily now write the given information. The mass is equals to 900 kilogram and the velocity is 10 meter per second. And don't forget, velocity is a vector quantity, so here the direction is given, that is toward east, so it specifies that this is something which is a vector. It must have some direction, and direction is given, right? So now what is required information? So required information is given in points A and B. In point A, what is asked? The momentum of the car. Calculate the momentum of the car. So we need to calculate P. Another thing that is given us is the change in momentum when the velocity of the car increases to 30 meter per second. So now final velocity is given, but what is the change in momentum? So now let's start with the part A. As we know, the formula for the momentum is equals to m times v, mass times velocity. Mass is 900 kilogram and velocity is 10 meter per second. So if you multiply these two, you will easily get the momentum of the car 9,000 kilogram meter per second. And this is initial momentum when car was moving with 10 meter per second. As the velocity is toward east, so momentum is also toward the east because both are vector and both have same direction. Now come to part B, and in part B, the final momentum is R, so m times Vf. So mass of the car is same 900. Just the final velocity is 30 meter per second. So we put 30 meter per second, and we will get 27,000 kilogram meter per second, which is the final momentum. So now we need to find the change in momentum. Here I explained with the help of formula. I draw arrows. So change in momentum is the final momentum minus initial momentum. Final momentum is what? 27,000, and initial momentum is 9,000, so kilogram meter per second. So we will get 18,000 kilogram meter per second. So this is our momentum. Yes, dear students, now you have to solve the problem 1, 2, 4, and 6 from page 166. on your notebook. 166, problem 1, 2, and 3, and 4, and 6. These are 4 problems you need to practice as a homework at your home. Good luck. If you find any difficulty, please don't forget to ask guidance.